the outline. So we're going to be talking about PhazeRo. Then we're going to go into what is data science and our data science team. Then we'll delve into the essence of what data science is and what is the backbone of data-driven projects. We'll also showcase our projects that we've been working in PhazeRo, as well as contemplating about the evolution of data science and data science projects and how they are affecting this industry, the tech industry in general. All right. So about PhazeRo. I guess most of you here know PhazeRo. So we're our team of experts who specialize in process optimization, data analysis, AI solutions. Okay, am I done? And we're basically, it's our mission to help businesses make data-driven decisions and leverage the power of this technology. So one of the things that makes PhazeRo unique is that we understand that businesses are different and they need their own custom solutions for their challenges. So that is PhazeRo, and we've been here now for 4 years, and inshallah for many years more. Okay, and now we're going to be introducing our data science team. So currently we're 8 members. The thing is about our data science team is that we are a diverse group. Okay, so we have different backgrounds and different talents, and they all converged to data science. So we come from different fields. So we have bioinformatics, we have someone from physics, computer science and engineering, obviously, mathematics. We have people who were business analysts, statisticians. So this is the diversity that we have. We have also people who have been in the industry for only 1 year. Others have been our veterans. So I think most of you know us, have worked with us. And yeah, that's our data science team. And now we go into what is data science. So this is a nice quote. So what is data science? So a data scientist basically is a person who is better at statistics than any software engineer, but is better at software engineering than any statistician. So data science is a very recent field, but that's the conception, the misconception right now. Data science has been here a long time ago. So in the 1960s, there was a thing called the data analyst, which is still available now. And then in the 1980s, the term was coined, data science. What happened was in the 90s, the computers became more and more prevalent. Then the focus shifted to handling data. So instead of just handling algorithms, now we need to handle data. And with that came something called data mining. And that's another term for data collection. Now, coming to the 21st century, data science grew into prominence, became recognized not just as a specialized field in academia, but also in industry. So it became a critical component of businesses and decision-making. So data-driven decisions. And in many publications, many magazines, you'll hear this term where it says like the hottest thing right now is data science, data science. So, okay. So basically, in summary, data science is a very relative field, but the term itself has been around for a very long time. Okay, so data science. Let's see, what is data science? So first, what do we do as a data scientist? We extract knowledge and insight from structured and unstructured data. So in our exploration of what data science is, we find that there's an intersection of various domains, okay? So it's multidisciplinary. So it's not confined to just a single area of expertise. Okay, data science employs the scientific method, the processing, algorithms, systems, and dealing with complex problems. Okay, we make data science particularly unique. It's very versatile. So one of the things is that we wear many hats. Okay, so that's why we're multidisciplinary. As I mentioned earlier about our data science team, we came from different backgrounds and we all converged to this field, which is data science. So one of the important things about data science is that we extract meaning from data. That is what data science does. Yeah. Okay. So to go deeper now, I want to talk about something called the data science life cycle. So what is the data science life cycle? So essentially, as its name suggests, it's a cycle. Okay, there are many aspects to this cycle, and we're going to go at each stage and explain each stage in detail. So first one is the business understanding. Okay, so the business understanding basically is the foundation on which all data science projects are built. Okay, it involves delving deep into the specific needs and challenges of the project or the business. Okay. So this is another quote. I like putting quotes. Quotes are nice. Okay. So in the end, you should only measure and look at the numbers that drive action, meaning that the data tells you what you should do next. So, reflecting on these words, it emphasizes the crucial aspect of data analysis. So we're concentrating on actionable data or making action out of data. So it's not just collecting massive amount of data, but extracting meaning from this data. And from this meaning, we make actions, and then from this actions, we can drive businesses, basically. Okay. I see in the chat there are people having issues with hearing me. So is everyone okay with the audio? Just check here.
Yeah, we can hear you fine.
All right. Okay. And then we go on to another quote. So in our world of big data, okay, businesses are relying on data scientists to glean insight from their large, ever-expanding, diverse set of data. So many people think of data scientists as a profession, and it's better to think of data science as a way of thinking, a way to extract insight using the scientific method. So we can say that you can be any profession and you can employ data science methods. So the business understanding. So the business understanding, as suggested, it's the initial phase. So this is where we define the objectives, the requirements from the business. We cover the knowledge that is needed, and basically we have the problem definition. So with data, firstly, of course, let me go to the next one. We define the objectives. Then we define the requirements. And therefore, we define the data science problem definition. Okay. So one thing, of course, is that I like to thank management. So the data scientist does not do this by himself. We do this alongside the project managers who give us insight and give us a clear path of what the business or the project requirement is. Okay. Thank you. All right. So basically, in the business understanding, when we talk about the data science projects, we delve into the heart of what we're trying to achieve. Okay, so we can break it down into a question. So one question would be, for example, how much or how many? Okay, now in this case, this is considered a regression problem. An example would be, for example, a company wants to predict next year's quarter sales, or let's say a real estate agency wants to estimate the housing price. And that's like a regular textbook example of regression, right? Another thing would be like, maybe we want to solve a problem concerning categorization, okay, or classification. So an example would be a bank wanting to know if they should give a loan out or not, so they can classify. This is like a binary classification. Healthcare, a lot of healthcare, they use diagnosis and they want to classify, for example, a tumor, if it's or like something is benign or malignant in terms of tumors. Okay, then we want to do clustering. So the difference between clustering now and grouping or categorizing is that we do not label that category, but we can find some patterns that are close to one another, and therefore we can cluster them together. Okay, so usually this is done in, for example, let's say biology. Okay, in biology, you wanna cluster certain species together, and you want to know if they are the same species or not, or there's the same class of animals or plants, etc. And then finally, we want to do something, for example, something that is weird. We want to detect weird stuff. We want to detect things that are not unusual. So this is usually mostly done, for example, in banks, fraud detection, cybersecurity, etc. Or maybe in an assembly line, you want to see if something's malfunctioning, is it working or not? And these are considered anomalies. Okay. And then, of course, we have the recommendation systems or recommender systems. And I think everyone has seen one of those before. For example, you're watching your favorite show on Netflix, and then you choose the like button or the like symbol, and that feeds to the recommender system, which then could recommend you better or similar movies, etc. All right. And then we go now to the next stage, which is the data collection. Okay, so what is the data collection? This stage is where we gather the raw data. This is another name for it also is data mining. So data collection is not just about getting information by itself. It's a deliberate process. So you have to know what you're collecting. And the key here is you want to gather data that is both of high quality and is related to the problem that you're trying to solve. So, of course, there are different sources of this data, and we're going to talk about this in the next slide. Okay. So, data collection, as we stated, is it's the gathering of data. We can gather it from a database. Okay. We can gather it from the web via web scraping. Another way of doing it is by taking surveys. Okay. Doing market research. And there are many, many more ways of doing data collection. Okay. All right. So when we're talking about data, there's two different types of sources. We have the primary source, and then we have the secondary source. Concerning the primary source, this is the first-hand, the original source of the information. It could be that it's generated directly from the source, and it's fresh, so no one has it before. You're the only one who has it, and then of course you can provide it to others as well. So, for example, studying customer satisfaction is considered a primary source. Doing surveys is a primary source. Now, with the secondary source, these are second-hand, as the name suggests. It means we get the information that is already there, already collected. This is information that has already been published, or even unpublished, but you didn't gather it yourself, or let's say collect it yourself, or let's say curate it yourself. Okay, so web scraping, for example, is a form of gathering secondary source of information. All right, and then we go on to the third part, which is the cleaning. Okay, so data usually does not come well packaged and ready made. Right, now you have to go into something called the data cleaning. So why do we do the data cleaning? It is very essential for preparing raw data and make it ready for analysis. So what does data cleaning involve? It involves refining the collected data, make it more suitable for study. What does it entail? It entails identifying, correcting errors, dealing with missing values, etc. So I'll go deeper into that when I go to the next slide. Okay, so one of which is, for example, we want to remove inaccuracies from this data so that it doesn't affect our analysis, right? We want to account for any missing data. So how do we deal with the missing data? Do we drop it completely? Do we average it out? This is all part of the cleaning. Then of course, after the cleaning, we do the analysis, and that comes afterwards, after the cleaning. Now, note, cleaning, and I think Warith will also delve more deeply into this part, takes the long time, very long time. And it takes longer than usually more than the other parts. So creating the models or doing the feature engineering or any of that stuff. Cleaning is a tedious task. It's not the most fun though. Yeah. Okay. Next comes the data exploration part. Okay, this is where we're doing the what we call EDA, exploratory data analysis, or data exploration and analysis. This is where we uncover the stories hidden within this data. So we've collected the data, we've cleaned the data. Now we want to explore it, understand it. Okay, we want to see if we can find any patterns, find any anomalies, maybe find some relationship between the data. Okay. So there's a lot of analysis and detective work involved in this part. Okay, so we call this also the brainstorming stage. It is the least structured stage of all the stages when we talk about the data life cycle, data science life cycle. So here you have to be very creative in finding relationships, understanding the data. Basically be a detective. Okay. So we have to figure out patterns, and we have to also figure out if there are biases or not. Okay. So I think you've noticed, like, for example, a lot of people say like ChatGPT is biased, and that's due to the data. It has been fed, right? So this is the case. If you want to create a model and you want it to be not biased, or at least reduce the bias, you have to do this part. Figure out where the bias is happening. Okay. And as I stated, this part has no particular structure. Okay. So what things can we do? We can get, for example, summary statistics. So one of which is, for example, finding the mean, the median, or the mode. This is just basically the central tendency of the data. When we go to the variance or the standard deviation, now we're going into the range of the data. How's the data spread? Yeah. And then part of the data exploration is we do some data visualization as well. Sometimes patterns cannot be found without this part. So we do visualization, we do correlation analysis, and there are tools that help in this regard. And of course, we do missing value analysis. Why is this data missing? What is the correlation between this missing data and the record that it belongs to? And as I said, it's unstructured. There's so many things that can be done here. All right, we're halfway through the life cycle. Okay. Now we go to the feature engineering. Okay, so what is the feature engineering? So this stage is where we apply our domain knowledge and insights. So this is where we create, let's say, features or inputs, or I don't know, meaning, I guess, from this data. So it's like getting the raw data, cleaning it, and now molding it into something that I could use. Okay. So let's go deeper into the feature engineering. So a feature is a measurable property or attribute of a phenomenon being observed. So now there's this famous quote from Andrew Ng. It says, "Coming up with features is difficult and time-consuming, requires expert knowledge. Applied machine learning is basically feature engineering." So with feature engineering, you cannot tell the data scientist, go ahead and do the feature engineering. Sometimes we need domain experts from other fields for solving a problem in that domain. We need someone to guide us, and this is where we need the domain expertise. So why do we need this? Because we need to create effective features. Okay, and as I stated, it needs a deep understanding of the domain. Okay, so what parts? What does feature engineering entail? So one of which is feature selection. So this is the process involving identifying and removing unnecessary features from our data set. So I'll give a simple example. Let's say you have a listing for a house, and then this real estate, this house has a feature that is the area in meters squared as well as in feet squared. So now we're having, okay, this is redundant information. We don't need it. So we can check the, for example, the feet squared. We don't need that. So here we're doing the feature selection. Then comes the feature construction. So what do we do here? Here we're creating new features from existing features. Yeah, so again, as I stated, to do this feature construction requires domain expertise and having good insight into the data. Okay, almost there. Yeah, stay with me. Finally, or not finally, sorry, there's one more. Then we go into the modeling. Okay, so what is the modeling? The modeling is the stage where our data science project starts to materialize. So here is where we have the product. We have something tangible that we can use. So here we apply various machine learning algorithms based on the problem at hand. We might use, as I mentioned in the beginning when we're talking about the business challenges, it could be something related to regression, could be something related to classification, clustering. The modeling, this is where it happens. So the choice of the model is very influential in how our product will perform. Okay. So the stages of this modeling. First, we do the building the model. So we try different machine learning algorithms, and here's where we do the training of base models, or we have already pre-trained models and we try them out. Okay. Next, we check out the performance. So we do some sort of evaluation. See that it does what it's required, and if it's dependable or not. Thirdly is we do the model deployment. So someone needs to use this model, right? It's not just a model for my own use. Someone has to use it. And then finally, we have to continuously monitor and update. So this is a crucial aspect, because you don't want your model to be obsolete after a while. So you have to always monitor it, and if necessary, update it. Okay. So when we talk about machine learning models, we'll talk about machine learning algorithms. So as I said, we have classification, regression algorithms, clustering, and there are hundreds of these algorithms that we can try out and use. In addition, of course, for each of these algorithms, there is also the evaluation. So for example, when we talk about classification, we're talking about one of which is accuracy, F1 score. Here we're using statistics. Okay. Regression, we look at the mean square error. Clustering, there's many. One of the most famous one is the Sowet coefficient. So there are many ways of evaluating your machine learning algorithm, and you have to know how to evaluate your machine learning algorithm. Okay. Then when we talk about the deployment, we have to know where to deploy this model, how we serve this model. We maybe use Docker containers, or serve them as a web application. Okay, and of course here we have to thank the software engineering team. They are the lead in this area, in this field. Okay. And then finally, as I stated, monitoring, we check the KPIs, check for data drift, we do A/B testing, and for this continuous integration and continuous development, we have to retain this pipeline. Okay. All right. Finally, okay, but it's not finally, it's a cycle. So once we're done with communication, we'll go back, right? So upon completing the modeling phase, we arrive at the final, yet not final, stage of the data science lifecycle. And that is communication and visualization. This is where we look at insights, look at the results, look at how the model is performing, how impactful it is. What else? So I'll go deeper into this in the next slide. So we display our findings in a graph and basically visualizations. Okay, maybe a PowerPoint presentation, for example. Okay, and this stage requires a lot of creativity as well. Okay, so other than EDA, this is a different type of creativity. Basically, you need there's a science to it. There's communication skills, and there's an art to this to visualizing and communicating your findings. Okay, and I've been talking this whole time, but of course we have to thank the design team in this regard. They are the lead in this in helping out, or let's say in leading the communication and visualization. So thank you there. And yeah, I've been talking this whole time. I need to ask people questions. Do you have any questions? How much did I bore you? Hello?
Done.
Everything good?
But you're not boring us. Yeah, we're still interested. So
Okay. All right. Yes, it's awfully quiet. I've been hearing myself this whole time, so I need to know if
everyone's focused. Everyone's focused. Don't worry.
okay.
We're enjoying this a
All
bit
right.
too much.
Yeah. Okay. All right. So let's talk about what is the data scientist time mostly used in. So according to a survey from Anaconda, most of the time we're doing is data preparation and cleaning. Then we do presentations, visualizations. Modeling is like 10%. Model training is another 10%. And then we have other things that are done as well. Okay, in contrast to 2003 survey, where they rank what they most use their time up in and what they don't use their time up in, we see that again, it's the same thing: data prep, data cleaning. So things didn't change. We're still doing all of this data cleaning and data preparation. And yeah, I'll give the mic to Warith, which is he's going to talk about tangible, more interesting things that we are actually doing in data science. So go ahead, Warith.
Thank you very much, Ahmed. Can you guys hear me well? Can you hear me? Everything's good? Okay, perfect. First of all, thank you everyone for joining us either in person or online, PhazeRo and otherwise. Your presence is much appreciated. Thank you, Ahmed, for the presentation ahead. I'll move on to kind of an application layer of the data science as we move forward. We first start by talking about different types of data science projects. I think there are multiple different types and kind of categorize them into three. So first of all, we have data pipelines and data staging. These projects, if you think about the life cycle that Ahmed mentioned, these projects mainly consist of the data handling, data cleaning, as it says in the slide, extract, transform, and load data. These are projects that involves collection, staging, storage, modeling. These are projects that we are collecting the data. We're not building anything. We're not concluding anything about the data. Think of it as organizing the data into a more retrievable format, into a more useful format for future analysis, for future reporting of the data. A different type of project is one that is more related to applying stuff with the data. So we have processing and analysis. These are projects that require applying different algorithms to produce reports, to produce visualizations, to produce different kind of outputs for the user. These are the most relevant types of projects that we see in data science. These are the ones that we work the most on because they produce the most tangible results for a client. And finally, we have an applications. This is something that is usually used with live operations. We need to collect data, live data. You can think of this, for example, in the recommendation systems where a live application is constantly running and we're collecting the data and returning and manipulating the data through the live application system. That's also something that is very used a lot. In data science projects, we have different stages. We have a life cycle, as Ahmed mentioned, but we also have we can take that life cycle and kind of transform it into something that is more befitting to whatever project we have. For example, in this case, we can define a problem. we kind of have the identification of scope, the definition. We move on to data processing, where we clean, transform the data. We build a model. We do the predictive algorithm regarding it. Then we evaluate it. We evaluate the model, make sure that everything is going good, everything is as we expect the data, the outputs to be. And then we move it to deployment. The reason I mentioned this kind of stage as in contrast to the one Ahmed mentioned is to highlight that we can take that original life cycle and modify it according to the project's needs. We can manipulate it to see what fits this project better based on the business understanding. We can also apply this stage to different tasks and apply the same life cycle to specific tasks. Moving on, I think we can talk about different projects that we have. I would like to hear some of the feedback from the team. Can you guess what project this is based on the projects? And I'm not going to accept answers from the data science team. I think anyone else that's not from the data science, can you recognize which project based on the picture on the right there? This is a hint, this is probably one of the bigger projects that PhazeRo has worked on. And I think more than half the team has worked on it. Should I answer? Is it SRO?
It's SRO, I think.
Very good, very good, very good. I think more than half the company has worked on this project. It's one of the more, it's one of the bigger projects. It's one of the most, the projects that we spend the most time on and we learned the most during. It's seismic route optimization project where we produced a route optimization algorithm for PGP and PDO to produce the best routes for a vibrator or a vehicle through a series of rough terrains and obstacles and navigating through that. We went through the whole life cycle of the project from business understanding to data collection, cleaning, all the way to building the models, different stages of the model. We didn't have just one model. We had different models to make sure that we're getting the best results possible, the best route possible. We take the results into consideration. We reapplied it and going through the cycle again, because as Ahmed mentioned earlier, it's a cycle. Once we get the results, we go through it all over again and analyze and repeat again. And I think the results have been amazing for SRO. I think everyone that has been involved in the team is very, very proud of how SRO went and concluded. I think we're still working on it. It's an active process, but I think it's one of the more rewarding projects that the team has worked on, as it applied every single aspect of data science. This is an earlier project. I personally was not involved in this project. Can you guys guess? I still want to hear feedback from the team. A hint is that it was probably around 1.5 to 2 years ago. We worked on this project. Does it ring any bells from the picture on the right?
Is it fantastic?
Close, but not quite.
RMG?
Close. It's HSO, hoist sequence optimizing. This is where we had to schedule, or the team had to schedule a small number of hoists to a large number of wells, while ensuring KPIs and maximizing oil output, minimizing well deferment. It's a classic data science problem. We're having to allocate a small number of resources to a large number of items. It's a classic data science problem. I think the most important part of this project was collecting data and making feature extraction, basically, to make sure that we're using the correct data to build the correct model from the data. Moving on, this is one that is ongoing. I think I created the picture using AI, so I'll be surprised if anyone gets it. But it's kind of self-explanatory if you think about it. Can anyone guess it? It's an ongoing project right now.
According to the picture, it seems like they're trying to fit the helmet on a board.
I mean, yeah, you're not wrong. They're trying to detect the helmets. We're working on a computer vision project. It's PPE detection. We're trying to automatically detect instances of non-compliance with PPE detection, raise an alarm, produce reports based on that. Based if the engineers, if the scientists or workers in the field are wearing the correct safety kit or not, and it's mainly a computer vision product. And we have other projects, but the last one I want to showcase here is also an ongoing project. I think a hint is that some of the team are having a meeting regarding that to discuss the future of this project. But can you guys guess from the picture?
Is it OpenESG?
It is OpenESG. It is one of the most trendy topics we have right now. It is the project regarding large language models, creating a chatbot for our client that answers questions regarding environment, social, governance factor, ESG. It is built on a database of over 600 questions, and it can answer very, very specific questions. If we go on to the next slide, I want to actually fit this chat ESG into the life cycle that Ahmed wanted to talk about and discuss it in more detail, as I think it fits the project pretty well, or the life cycle pretty well. When we first got the project, we met with a stakeholder multiple times before we even got started with the project. And the reason for that is to understand their vision, to understand the requirements, the work, and the timeline. The reason for this is very important, as to clear our assumptions with what the client or what the user wants. We want to make sure that everything that we think that we're supposed to do is the correct thing. So yeah, we will move on to the next section on the life cycle, which is collecting the relevant data. We had the client provide us with a series of over 600 related documents, ESG related, and the client provided most of these. We collected them, we cleaned them. I think the data, as Ahmed mentioned, the data cleaning of this project was the roughest. We extracted every single table, every single infographic from those reports, from those PDFs, and converted them into a format that a large language model could understand and could provide accurate results regarding. So once we do that, once we made sure that it's extracted, it's clean, we put it in a shared drive. Then we move on to data analysis. Everything has been extracted, everything has been documented, everything's on OneDrive. We go on to follow the same structure as before. We evaluated if the tables are in the expected format, and we converted the extracted data into vector embeddings. Vector embeddings, if you didn't have a background on it, is what the large language model can base its answer upon. It's the format that can be retrieved by the large language model to perform a similarity search. We move on to the next stage of the life cycle. We go for feature extraction, or rather feature appending in this case, where we attached metadata to the clean PDFs. The reason for this is to make sure that the data we retrieve is accurate, to make sure that if we ask a question regarding a company, we're getting the correct data regarding that specific company. This is to confirm our results, and we used it later in the evaluation. The modeling took was the most fun part of this project, as is with any other project in data science. We created the large language model structure. This includes the use of retrieval chain, the large language model prompts, etc., evaluating different models. We built an evaluation module to confirm the results, as I mentioned, with the feature extraction. It used parts of that to do the evaluation. And this process included a lot of trial and error. This is something that we have a lot in data science, where we kind of have an assumption and then we experiment. We're scientists. We're having, we don't always know the right answer. So we experiment, fail, and try again until we are confident with our results and with our success criteria. Yeah, then once the behavior was perfect, we moved on to the communication, visualization. We created a platform for the user interface, managed it by Docker, and hosted the system on AWS. And last thing I want to mention is that once we delivered every aspect of this lifecycle as PhazeRo promotes in the best way we could. And this included delivering the final product. And Once we did that, we're now back into a different scope of the project as the client was extremely satisfied with our results. We move on to a different, bigger scope of the project where we'll be going through the cycle again of understanding the new scope, implementing, cleaning, and going through it again, but with a bigger scope. And that's why we try to do every part of this life cycle to the best degree possible. Taking a step back and thinking about a step forward with the future landscape, I think there are very promising things regarding data science in the future. It's trendy, as they say, especially in artificial intelligence and machine learning fields. They dominate data science, or at least the stuff we see most online about, especially with automated decision making, with predictive analysis and deep learning and natural language processing advancements. This brings up not a problem, but a thought of ethical considerations in the future. I know a lot of you have heard of how can we kind of confirm that these results are correct, or something is real, because artificial intelligence can generate anything. It's generative AI after all. I think the world is thinking about it. We're thinking about creating responsible AI and machine learning models. We're making sure that we are reducing bias and fairness concerns in the future. We're making sure that the user data is private and secure, as I know a lot of companies are making sure that the user's data are their highest priority, and they try to promote that in a world where privacy is scarce. User data is being shared everywhere. So that's where we're trying to, at least as a company. There are also fields with augmented analytics, as I mentioned, natural language processing, with automated data preparation. Is this part going to lead to more opportunities in the future or less opportunities? This is a question that only us as data scientists or as engineers, as developers, will find out in the future. Are we is AI going to help us with our jobs, or is it going to do our jobs better than us? We still haven't gotten to that point yet, but we'll see, as well as augmented data discovery. One last point I want to mention is that with this increase of scope of data science increases the process of interdisciplinary collaboration, which is collaboration with domain experts. Was it through platforms that PhazeRo provide us with domain expert through different channels, or was it with translating data insights into strategies or enhancing problem-solving skills through communication with different disciplines? That takes me to my final point of the presentation. Thank you for bearing with me so far. Data science and others. As you guys know, PhazeRo is not a data science exclusive company. We have different fields, different roles in the company. I think this is a point for us data scientists to take on, as well as a point for the rest of the team to take on. The purpose of this workshop, the purpose of trying to kind of open the team's eyes to data science is to foster this cross-team collaboration. We are doing a great job at it, but there is no harm in improving the stuff that we don't know about. A point for us is we shouldn't be data gatekeepers. Data scientists shouldn't be, in a sense, isolated as the stereotypes say, where we understand what we're doing, but we're not sharing that with anyone. So this is the purpose of this workshop. We're trying to kind of open everyone's eyes to what we're doing behind those Python scripts. We want to know the other teams, either on a personal level or a technical level. Something that PhazeRo does really well is being having the leadership on board regarding on a management level or on a higher level. I think very supportive of the data science team, as well as the cross-team collaboration. And the purpose of this workshop, and you will hopefully see the value of it in the next one or the next couple, is the teaching data science, how data science can add value, with actually applying data science in case studies and many projects that we're going to have in the future iterations of this workshop. Yeah, and finally, I think this is a quote as Ahmed shared a couple. I wanted to share one of my own. I found this online and I thought it was cool. Is that sometimes I'll let you guys read it, but the most important point in here is if you bring them on a journey, you become better because you understand what they're trying to do better. don't always expect that people are going to meet you halfway. That's fine if they don't. Going that extra mile, as was it me as a data scientist or someone else, Ahmed as a software engineer, if we go that extra step to try to make each other better, we'll learn across the way, and I don't think that's time or effort wasted by doing that. So even if we don't meet halfway, I think going that extra step will foster that learning experience through the teams. And yeah, that's all I had to present. I'll open the stage to questions either for me, for Ahmed, or the rest of the data science team.